Risk. It's all around us, every day. We all know that there's no situation that is risk-free. So when do we accept risk? And how much risk is acceptable?
Risk is acceptable under three circumstances: when it's insignificantly low, when we're sure it's worth it, and when we do not know it's there. And that's the whole point of the risk assessment.
People are drawn to risk assessment for very different reasons. Whatever the driver, one thing is becoming more and more obvious. Risk assessment works, and it takes work.
Risk assessment is really a journey. It's not an event. It's not something that you do once and you're done.
It takes time, interrupts people, 2 to 3 days on a typical machine, but after that, it gets easier and easier each time you do it.
Today we tend to do a lot of safety work after we release the product, after we release the system. And tomorrow what we want to get to in Safety Through Design is getting us to the point where we're doing safety up in the design phase.
There are a number of different methods and tools available to do risk assessment, but generally the process is to identify the hazards, assess the risk, reduce the risk, and then document the results. For example, the new packaging standard that applies to both end users and suppliers of packaging machinery does not require that the level of risk is zero. It requires that risk is reduced to an acceptable level. Of course, what's acceptable is somewhat subjective, and that means you need to get comfortable with the subjectivity. In the area of machine safety, many start with the hazards of the actual machine. But Bruce Main, author of Risk Assessment, Basics and Benchmarks, discusses a slightly different and fresher approach.
One of the newer aspects of risk assessment is the task-based approach. And task-based is really where you dig down and understand what people are doing with your systems, your machinery, your designs. And it's by doing task-based that you can really identify hazards that you don't otherwise see and then reduce risks associated with those.
That's where you need to focus your efforts. Don't get hung up making it a scientific exercise. It isn't.
New tools like this software guide you through the risk assessment process. It's not an expert system. It doesn't tell you what to think, but it guides you on what to think about. So it helps you to identify users, a list of users that might be involved in your activity and the tasks that they are performing. The next level, you look at hazards, and you're able to identify then hazards associated with the tasks. Now what you get from this is a documented risk assessment that's required in the different technical standards and reports.
Sometimes hazards are designed into machines or systems. That's because the tasks are not anticipated. This occurs on both older and newer machines.
In all the years I've been doing safety and working as an engineer, I've never seen a circumstance where an engineer identified a hazard and didn't